Today we're going to take a look at section 2-1 on summarizing and graphing data. Our two learning outcomes are as follows. After this section we will be able to construct a frequency distribution, a relative frequency distribution, and a cumulative frequency distribution given a set of data. Second of all, we'll be able to determine the midpoints, the upper and lower class limits, the class width, and the boundaries for the classes in a frequency distribution. So Chapter 2 gives us some tools to understand the data set, and you'll see that we'll be doing a number of summarizing tables and also graphing. There are some important characteristics of data that we'll be talking about as we go through Chapter 2. First of all is the center, which is a representative or average value that indicates where the middle of the data set is located. Variation is a measure of the amount that values vary from each other or among themselves. Distribution, we'll look at the graph and talk about the nature or shape of the distribution of the data. We'll be interested in outliers, which are sample values that lie very far from the vast majority of sample values. And time, we have to make sure that we understand the changing characteristics of data over time. In 2-2, we talk in particular about a way of summarizing data in a table, and we talk about what are known as frequency distributions. A frequency table lists the classes of values along with the frequencies of the values that fall into each class. We have the lower class limits, which are the smallest numbers that belong to different classes. We also have the upper class limits, which are the largest numbers that belong to the different classes. We have class boundaries, which would be a point halfway between the upper class limit of one class and the lower class limit of the next class. Class midpoints are found by adding the lower and upper class limits and then dividing that sum by 2. And finally, class width is the difference between two consecutive lower class limits. One way to calculate the class width, if you're not directed what to use for the class width, is to find the difference between the highest and the lowest data values and then divide the difference by the number of desired classes. Just remember, when you're making a frequency table, you want between 5 and 10 classes. You don't want less than 5 and you don't want more than 10. So when we're constructing frequency tables, we want to keep within those boundaries. Once we have decided, say we're dividing by 5 or we're dividing by 6 or whatever, then we take that answer and round up to the next highest number or a convenient value. Now, very often when you go through the process that's discussed here, and let me get a pen. Okay, pen. My ink tools don't want to wake up. There it comes. Okay. You may end up actually with one more class than you originally intended. That looked like a P. So, and you'll actually see this in the example that I have here. Okay, there are some things we need to remember when constructing frequency tables. We want to be sure that the classes are mutually exclusive. That means that each class value or each value should belong to one and only one class. We want to include all the classes even if the frequency is 0. We want to try to use the same width for all classes. We want to select convenient numbers for the class limits. We want to use between 5 and 20 classes, and we want the sum of the class frequencies equal to the original number of data values. If it doesn't equal the number of original data values, then you have an error somewhere in your calculations. Okay, so I have constructed a frequency table of final exam grades for one of my classes. And I have the numbers listed here, starting with an 86 and ending with the 81. And what I did was I located the highest score, which was a 90, and the lowest score, which was a 64. And I took the difference between those two. I got 26. I decided I wanted about six classes, so I got 4.3. And when I looked at 4.3, I figured the most convenient number to work with would be 5. So because the lowest number is in the 60s, I decided to start with 60. And then with a class width of 5, my next lower class limit will be 65. Add 5, add 5, add 5, add 5, and add 5. So we end up to 90. Now, you'll notice originally I wanted 6 classes, and I actually ended up with 7. See, I divided by 6, I actually ended up with 7. Okay, now, that's because of the way I chose the 5 and to start at 60. Okay, now when we go, we want to stop one number before 65. So first class limits, our lower class limit is 60, upper class limit is 64. Lower class limit of class 2 is 65, and then when I add 5 to the 64, we get 69, which is 1 less than the 70. Add 5, we get 74. So these are our classes. You can see you can add 5 all the way down. So these are the lower class limits, and these here are the upper class limits. Okay, then what I did was I went through and counted how many I had in the category. Let me erase. I want to erase. See if I can get my eraser to work. Okay. How many I wanted to in each class. So from 60 to 64, I have, let's see, whoops, that's not in that range. I have just that one, it looks like. Okay, so my frequency is 1. From 65 to 69, okay, now I want that one. 1, 2, 3. Okay, so I have 3. And 70 to 74, 1, 2, 3. And that's it, so I have 3 of those. And so forth. That's the way I constructed the table. So if I were doing a frequency table, it would consist of just those first 2 columns, the scores on the test or the exam, and then their frequency. That is a frequency table. Now, if I want to go on and do a relative frequency table, what I do is I total the frequencies, and there were 30 people in the class. So 1 out of 30 gives me a frequency of 3.3% or 3.33%. 3 out of 30 is 10%. Again, 3 out of the 30 is 10%. 9 out of 30 is 30%, and so forth. So I'm stating the relative frequencies as percentages. So if I wanted a relative frequency table, it would consist of the scores and then that relative frequency column. Of course, I always find it convenient to do the frequency column simply because you need it to compute the relative frequency. All right, to find the midpoints, and the midpoints are used when we go to graph our frequency tables. So the reason we use midpoints are for graphing and also when we're calculating from a frequency table. And also boundaries can be used for graphing, so that's the reason we want to know how to get those. All right, the midpoints are found by adding 60 plus 64 and then dividing by 2. So I'm adding 60 plus 64 I get a sum divided by 2, and that gives me a 62. So the next one's 65 plus 69 divided by 2 gives me 67, and so forth. So we add the two, the lower and the upper class limit of the class, and then divide that sum by 2 to get the midpoint. Boundaries are a half a step before the lower class limit and a half a step beyond. So we'd be at 59.5, that's a half a step before 60. Half a step beyond is 64.5. Notice 64.5 is halfway between 64 and 65. So that's where we're getting our boundary from. Halfway between 69 and 70 would be 69.5. Notice that these are the same on the boundaries. So very often on the histograms we'll use the boundaries on that particular graph. Sometimes they use the midpoint, sometimes they use the boundaries. Alright, so and typically these two columns, the midpoints and the boundaries, are not put in the frequency table. I put them here so that when we get to our next section we can use it to actually do our graph. Alright, let's see if I can get enough of this to show. Okay, I want to be able to load frequency. Now, when you go to the cumulative frequency frequency table, what you have to do is add up the numbers from the frequency column as you go along. And what we do is we say less than 65. Notice this class, and I think it may be just out of your view, this first class is everything less than 65. So we only have 1. So I've got a 1 there. I'm just going to check it off. Okay. Alright, so we've done the 1. Then less than 70, we have a 1 plus a 3. So less than 70, we have 4. Okay, less than 75, we have a 1, a 3, and a 3. So if we add those, we get 7. So less than 75, we have 7. Less than 80, we have 1 plus 3 plus 3 plus 9. So that's going to be 7 plus 9 would be 16. Okay, and our next one would be 1 plus 3 plus 3 plus 9 plus 8. So 16 plus 8 would be 24. And then we add the 4 to that, it'd be 28. And then finally we add the 2, and that gives us 30. And we'll also talk about creating an ogive from this particular table, from a cumulative frequency table. So typically your frequency table is only going to have 2 columns. I put them all together here simply to make it easier for us to follow, so I wouldn't have to repeat the numbers again and again.